All right, section 7, logical reasoning and counterexamples. Okay, so the first logical reasoning thing we're going to talk about is conditional statements. These are usually written in the form, if something happens, then something happens, is kind of how this goes. So a conditional statement, if such and such, then such and such. So if popcorn burns, then the heat was too high or the kernels heated unevenly. If this such and such happened, then such and such happened. If then statement is just another way of saying it's a form of a conditional statement. Sometimes they're interchangeable. There are some other things that could be conditional statements, but pretty much for this lesson, just think they're interchangeable. If then statement, conditional statement, same thing. Hypothesis, the part of the statement immediately following the if part of the statement. So if the popcorn burns, that's the hypothesis. That's what we're curious about. The conclusion is the part after the then statement. So then it is overcooked. If the popcorn is burned, then it is overcooked or whatever they had there a little bit ago. Deductive reasoning. Brilliant deduction, Watson. The process of using facts, rules, definitions, or properties to reach a valid conclusion. Really what that's going to be in a lot of our stuff is we're going to use the addition property of addition or the identity properties. We're going to use those kind of properties in order to come up with a conclusion about something. So if a mathematical this is that, then this, and we're going to use different facts or rules or properties that we know in order to say that, yes, this is actually true. So a counterexample is a conditional statement is false only when the hypothesis is true, but the conclusion is false. So that would be like a statement. If you live in California, then you must live in Los Angeles, in Southern California, where it's warm and the beaches are beautiful. And yeah. So is there a counterexample? Duh. Because I live in California, but I live in Lodi. So this makes the statement up here false. Because we said the conditional statement is false when the hypothesis is true. I live in California. Then you must live in Los Angeles. Well, I live in Lodi. So that makes this whole statement false. All right, so let's see what some of these look like in some homework problems here. Identify the hypothesis and the conclusion of the statement. Should be fairly easy. If it is raining, then John and Chloe will not play softball. So sad. I want to play softball. So recall the hypothesis is the part of the conditional statement following the if. And the conclusion is the part of the conditional after the word then. So, hypothesis, it is raining. Conclusion, John and Chloe will not play softball. Poor people. All right, hypothesis and conclusion again. If 7y plus 5 is less than or equal to 26, then y is less than or equal to 3. So hypothesis, 7y plus 5 is less than or equal to 26. Conclusion, y is less than or equal to 3. All right, pause this one, give it a shot. All right, if it is above 75 degrees is my hypothesis, then you can go swimming. Conclusion, hypothesis. If it is above 75, conclusion, you can go swimming. It's just matching them up. All right, let's try a little more difficult one. Right, if 2x plus 3 equals 5, then x equals 1. So hypothesis, conclusion. 2x plus 3 equals 5, and then x plus 1, d. Write a conditional in if-then form. Identify the hypothesis and conclusion of the statement, then write the statement in if-then form. I eat light meals. Hypothesis, I eat a meal. Conclusion, it is light. So if I eat a meal, then it is light. Let's try another one. For a number a such that 8 plus 5a equals 53, a equals 7. So my hypothesis is for a number, 8 plus 5a equals 53, conclusion, a equals 7. So if this set of numbers, then a equals 7. Because if you actually did all the mathematics out, subtract 8, divide by 5, it would come out to a equals 7. Pause this, give it a shot. All right, then write the statement in ifs-then form. We go bowling on Fridays. So if we're bowling, then it must be Friday. Should have hit pause there. Oh well, keep going. See if I'm right. Hypothesis, if it is Friday, then we are bowling. If it is Friday, then we go bowling. Yay! All right, pause this one, try it out. I think they made these a little too easy because really it's just go, for a number such that this happens, then x is less than 2. So if 11x, hypothesis, 11x plus 5 is less than 21, conclusion, x is less than 2, hypothesis, conclusion, if this, then this. So that would be in B. All right, so here's some of that deductive reasoning. We're going to use facts to justify something. So determine a valid conclusion that follows from the statement. If one number is odd, then the other is even, then their sum is odd. For the given conditions, if a valid conclusion does not follow, write no valid conclusion, explain why. For two numbers, so we're going to take one odd number and one even number, their sum has to be odd. That's what they're asking. If this, then this. So let's try it with a couple of numbers. An odd number, 5, an even number, 12. We add them together. 5 is odd, 12 is even, so the hypothesis part is true. So the sum of 15, conclusion, the sum of 5 and 12 is odd. So therefore the hypothesis would be true. Determine a valid conclusion that follows from the statement. If one number is odd, the other number is even, then their sum is odd for the given conditions. If a valid conclusion is not, like, gotta keep going. All right, so let's try. Two numbers are 8 and 26. Both numbers are even, therefore the hypothesis is false because it says one number is odd, one is even. They're both even. This isn't going to work. So there's no valid conclusion. All right, pause this one, give it a shot. Okay, so it says if the last digit of a number is 0, then the number is divisible by 10. Okay, so we'll look at this number. Is the last number 0? Can we divide it by 10 evenly? Yes. So yes, the number is divisible by 10. Let's try this one out. All right, determine if this valid conclusion follows the statement. If the last digit of a number is 0, then it is divisible by 10. For the number 4,205, its not last number is not 0, so we can't even test this. So there's no conclusion. All right, so this is one that could be in like an SAT or one of your test questions because we do a lot of multiple choice. Which numbers are counterexamples for the statement below? X minus y is not equal to y minus x. So if it is x minus y is not equal to y minus x, you're just going to have to substitute them in probably. So find the values of x and y that make the statement false. That's when we're talking about a counterexample. So substitute them in. Which ones don't work? So we replace them in. So the hypothesis is true, but the expressions are not equal. So the statement's true. So the hypothesis was if you flip x and y, they're not equal. So 4 and 4. Oh boy, here might be the one that gets it. 4 minus 4, 4 minus 4 equals 0. So the hypothesis original of x minus y is not equal to y minus x is false by a letter B. Try the other ones real fast. 0 minus 1, 1 minus 0, not equal. So therefore that one's true. 7 minus 7 would actually come out to 7 plus 7. So 14 and negative 14. So that one is also true. So the value that proves that the statement false would be the counterexample, which, so 4 and 4 together would be the correct answer. All right, find a counterexample on this one. Go. All right, so we need to find one of these together that multiply that is not less than or equal to 1. So 1 times 1, is that less than or comes out to 1, equals 1 is greater than or equal to 1, so that one's true. 1/4 times 2, is that greater than or equal to 1? 4 times 2 would be 2/4, which would equal 1/2. That would be less than or equal to 1. Hate it when it does that. 1/3 times 9 is less than or equal to 1, comes out to 9/3, which equals 3, is greater than or equal to 1. That one's true. 0 times negative 2, is that less than or equal to 1? 0 times negative 2 is 0. Is 0 less than or equal to 1? I feel I messed up somewhere. Oh, yeah, that would have been false, because 3 is greater than 1. Duh.